Welcome back, dear students. I am Advait back here for teaching you and for inspiring you to gain success in your life. So I hope you will share this video, you will like this video. Please like this video first. Everyone please like this video, that I will get energy and enthusiasm to teach many people around me. Yes, and please comment your opinions, your doubts, etc. and for sure I'll be replying to it. And please share and please subscribe to our channel. Like every day I'm posting about 5 to 6 videos I'm planning to post. Yes, think my determination from morning to evening. I am determined to teach you. My determination. So I hope I'll be rewarded for it. I want just not a fees and all. I just want likes, I want subscribers, I want shares and comments. I hope you'll do it. Without much ado, we'll be moving on to the next part, that will be optical instruments. This is also a very important part, but simple. It was just directly applying formulas. Before that, I would like to tell you something, is that about near point and far point. Near point is the distance of least vision. You know that you can take a book. Your eyes is here. Your eyes is this. This is your eyes. Eyes here. You can take any book and you are reading something written in there. If you keep the book in a if you keep book within 10 centimeters from your eyes, it is you cannot read the book. With 10 centimeter, you can just try. Take a paper, keep 10 centimeter within your eyes, you can read anything. But if you keep it 25 centimeter from our eyes, we can read it. But we need to apply stress. But still, stress means what? Eyes, strain for the eyes, not the other longitudinal stress and all. Normal stress, English word stress. No, nothing. We have eye strain. But still we can read. So 25 centimeter is known as the near point for human vision. That is the least distance at which we can view something. The least distance of vision. So please note this, 25 centimeter is the near point for humans. And far point for humans is infinity. That you know that we can see, if I am standing here and there is sky, a pandu is standing here and there is a sky. There's a sky here. And you know that sky is there are stars in the sky. You know that stars are infinite distance away from us, very very large distance away from us. Still we can see the stars. So the far point for our eyes is infinity, that we can see images at infinity. That's the reason why we can see stars in the sky. So our far point, that is maximum distance of our vision, is infinity. This is the thing. Before optical instrument, I would like to tell you. Now we'll be going on to optical instrument, that is simple microscope. What is a simple microscope? It is just normally a concave mirror. Just a normal concave mirror is called as simple microscope. I should draw it better. Why does this look like this? I think I'll draw something like this. Yeah, you can take this as the mirror, because usually for you and all, it will be given like this. Okay. 1 second. It went somewhere. Something is happening here. Sorry. Yes, so this is our telescope, simple microscope, that we have one convex lens and there is a ray coming from this and going like this, okay, and one passing through curvature. Okay, 1 second, I'll make this line better. Okay, one second. Sorry. Sorry for the disturbance happening here. Yes. So now when you elongate it backwards, somewhere it meet and you get a enlarged image. This is called simple microscope. Just a simple. Here is your focus. Just a simple. Convex lens is called a simple microscope. Now image at near point. So for image at near point, the magnifying power of the lens. This is not magnification. It is magnifying power. So magnifying power for the lens at near point. So near point is 25 centimeters. So we'll put near point. Near point. We will show it as D. We'll show it as D. So for image at the near point, because that's the minimum distance where the image should be found, that we can see the image clearly. You know that when the image is coming near to us, it will be more visible. So at our near point, the image will be more visible, more clear. Still we have stress in our eyes, difficult for us to view it, but more details can be seen it if we apply focus on it. So it's a better image. So image at near point, the formula for magnifying power at image at near point is 1 plus d by f, where d is near point, f is the focal length of the mirror. Very important formula, used in all other cases also. So it's important. Now if we need image at where, not near point but at far point, that is infinity. The formula for magnifying power then is just d by f. No need of 1 plus, just d by f. So these two formulas are important. Okay. Yes. Next we have compound microscope. Okay. Yes. Compound microscope really has one small lens and one big lens. This big lens is called eyepiece, and the small lens is called objective lens. Okay. In this thing you have to understand is that the image will be here, the object is here. It's a very small object. Now what happened? A ray is coming and it is passing through the focus. One second. Focus and going. Yes. And now another one passing through the center of curvature and going. You think the center of curvature is here. It's very difficult to draw problem. Now this is reflecting once again. Yes. Now extend it. So we have a magnified image here. That's it. Now when these two lines are meeting, so we have a small image here. This image is acting as the object for the image. So I'll tell you something. This is the image formation in compound microscope. Now tube length. What is tube length? It is V of object, that is this virtual object is really image for this big eyepiece lens. Still this virtual object, the distance from the small objective lens to this virtual object is VO, and the eyepiece, to eyepiece it acts as what? This acts as virtual object, act as real objects for which one? Eyepiece. So this is UE. So tube length means total length between two lenses, that is V objective plus UE. Learn it. Important. Okay. Yes. Now magnifying power equal to magnifying power of objective lens into magnifying, this is not cross product, it is into, my god, magnifying power of objective lens multiplied by magnifying power of eyepiece. You know that for magnifying power of eyepiece, if the image is formed at near point, that is least vision point, then magnifying power of eyepiece can be written as 1 plus d by fe. And if it is far point, then we can write it as just normally, which one, d by fe. Okay. Now for objective lens, magnifying power equal to v of objective by u of objective. Normally magnifying power of a convex lens is what? Magnifying power of convex lens, yes, v by u, that is v naught by u naught. But if tube length is less, if the tube length is very less, comparably less, like if tube length is very less, or if focal length of two mirrors are not comparable, that is one focal length is very less and other focal length is very big, then you can use one more formula. Only at this special case you can use this formula, that is m objective is equal to L by f naught. Special condition only, okay. So this is the formula. Now you can apply it accordingly what they are telling. So this is about compound microscope. Third one, telescope, that is astronomical telescope. Look, this session only aims to provide you with the enough formulas that you should by heart. Okay. So for astronomical telescope, it's very different. The objective lens is having big focal length and the eyepiece is very small. Something like this. So what happens is that really the object is at infinity. So one second. The object is at infinity. And what happens? One second. We should touch it there. We should be able to. So I will make this lens somewhat bigger. Somewhat bigger means smaller than the other one. Okay, one second. Sorry. Yeah, I'll draw it like this somewhat. Okay. So one second. It will be going like this. It will be going like this. Now it will be going like this. Now you can extend it, and you get a enlarged image. This is for here. Big lens is objective, small lens is eyepiece. Here it was small lens is objective and big lens is eyepiece. Opposite. Okay. Here the tube length is f naught plus fe. That is f objective plus f eyepiece, or the tube length can also be written as v objective plus UE. The same way. Okay, no need to explain, just by heart, very important, by hearting this simple formulas will help you in JEE Main, because in JEE Mains you need the formulas in your fingertip, but for JEE Advanced you have to do it taking effort, you have to solve each and every problem, so that they both are different. For JEE Mains, by heart, whatever you can do, by heart small equation, apply it, you get the answer. And you should also use some concept for some difficult questions and you will get the answer. Okay, now for near point, the magnifying power is f naught by fe 1 plus fe by d. Just by heart it. Magnifying power on the near point. For normal vision or for far point, that is far point, it is f naught by fe. Just f naught by fe. These two equations are important. Okay. So this is about astronomical telescope. Now we are having one more thing known as Cassegrain telescope. Cassegrain telescope. So I'll be 1 second. Give me 1 second. I'll be taking the photo of Cassegrain telescope from your textbook directly. Yes. So this is the telescope given in your textbook. 1 second. This is the telescope given in your textbook. This is telescope. The proper ray image. Look, F0 plus Fe is the tube length. F0 plus Fe. Okay, you got it. Now I'll show you for compound microscope also. This is given in your textbook. Compound microscope. Really. Tube length. Tubular. Yeah, look. L by here the only this equation is given, but this is always for what? Short tube length. Short tube length. This is for always short tube length. Don't forget it. Okay. Yes. Now this is the telescope I told you. Yes. For these reasons, modern telescope use a concave mirror rather than a lens for objective. Telescopes with mirror objectives are called reflecting telescope. This is a special type of telescope, that is Cassegrain telescope. This is a Cassegrain telescope. They can ask you questions from this because this is a reflecting telescope. Here concave mirror is used, not a lens. A mirror is used. So we'll read this lines from NCERT. There is no chromatic aberration in the mirror. Okay. Look, why? Before this, we'll go through this things. 1 second. The reason for the failure of normal telescope is that it is very difficult and expensive to make large sized lenses which form images that are free from any kind of chromatic aberrations and distortions. Because if you are making big lenses can lead to chromatic aberration, means light splittings, because it is a refraction, right? It is a refraction. Light splittings can be large, but for mirror, light splitting is not there. No dispersion is happening, right? No dispersion in mirror, so this is just reflecting back like this, right? So mirrors are better than lenses because no chromatic aberration. So no chromatic aberration. If they need, they can ask you assertion and reason question. Okay. So no chromatic aberration in a mirror. Mechanical support is much less a problem for a mirror, weighs much less than a lens of equivalent. One more thing is that mechanical support, because mirror weighs less than lens. So therefore mechanical stability for holding a mirror is simpler than a lens. So that's also a plus point. This no chromatic aberration. So 2 advantages of Cassegrain telescope, and can be supported over its center, not just over its rim. One obvious problem is this thing. So they are telling that this telescope is better because it uses what? Mirror. It is better. So please read this. The name of that reflecting telescope is Cassegrain telescope. We can read this. The thing is that here they use a mirror instead of a lens. So with this, we are coming to an end of the chapter. And one more thing is there a fun fact. The largest telescope in India is in Kavalur, Tamil Nadu. It is a 2.34 diameter reflecting telescope, Cassegrain. It's a Cassegrain telescope. Just underlined and kept simply for general knowledge. For NEET and all, they can ask if they need. Okay. Yes. So by this we come to an end of the chapter ray optics. For derivations, you can check the textbook, because look, for prism the derivation and all is given here. Prism. Now for combination of lenses, it is given here. The combination of lenses, no need of derivation and all. For power of a lens, it is here. Now for reflecting surfaces, everything is here. So you can refer. Thank you and have a nice day. I'm leaving. Bye. Please share, please subscribe, please do everything. You can do and support me. Thank you.